Okay, everyone. Before we go deep into load balancing, I want to clear one very big confusion that almost every NSX learner has. Okay, so in NSX 4.10, VMware provides two different load balancing. Okay, so one is the distributed load balancer, another one is NSX advanced load balancer. Okay, so you need to remember this two. Okay, and both are like having different features, and they are not interchangeable. Okay, and they are not designed for the same purpose. So most people assume that NSX has only load balancer, or they think a distributed load balancer, and AVIs are just different names. That assumption is wrong, and in production this mistake can cost money and create design issues. So you should have a good understanding, like what is distributed load balancer, where exactly this DLB will used in the production support, and also you need to understand what is NSX advanced load balancer, in which scenario in production support we'll be using this NSX advanced load balancer. Let's try to understand some basics about distributed load balancer and AVI load balancer. This distributed load balancer is designed to work inside the NSX fabric mainly for internal traffic. And this NSX load balancer is designed to work like a full enterprise load balancer. You might have seen some load balancer like FI, then Citrix and Scalar and all, right? In the past, we worked with the network team on this, right? So this AVI is mainly used for external and complex application traffics. Okay. So from this slide, just keep one point clear in your mind. So NSX 4.1 has two load balancer. Both are different and both exist for different production use cases. In the next upcoming slide, I'll explain clearly to understand where each of this load balancer runs, what features each load balancer supports, whether license is required or not, and most importantly, when to use which one to use in real-time production support. So if you understand this concept, rest of the topics like related to this load balancer is very easy to understand. Now let's try to understand the first load balancer, which is the NSX distributed load balancer. The most important thing you must understand here is distributed load balancer is kernel based. That means it runs inside the ESXi server itself. It does not run as a virtual machine, or it does not run as an appliance. Okay, so there is nothing extra to deploy to enable this distributed load balancing option. Once your ESXi host is prepared with NSX, the distributed load balancer capabilities, like it's already enabled there. And this works very closely to the virtual machine because it runs inside the ESXi kernel. Okay, and traffic does not need to go to any external device or edge node. Load balancing happens inside the ESXi host and near the virtual machine VNIC. That is why this DLB performance is very high and the latency is very low because it's very close to the VM, right? I'll show you some topology diagrams so that you can understand like where exactly it interacts with the VM. Now I want everyone to focus here because this is an layer 4 concept, okay, and which may confuse many people because when we say distributed load balancer, it's supposed only layer 4. Okay, so what is layer 4? See here, I just shared an table with some layer 1 to layer 7. So here in layer 4, it is going to use a protocol called TCP and UDP, right? So here layer 4 means the load balancer looks only at IP address and port number. That's it. Okay, it does not look inside the application data, and it does not understand HTTP URL, headers, or cookies. Okay, so I'll give you an example. Okay, so that you can understand this in a better way. So assume you have three backend VMs are running the same application, like VM1, VM2, VM3 on this example. All three are listening on TCP port 8080. Now a client VM sends traffic to a virtual IP on this VM. Okay, the traffic will be passed to all these three VMs using some backend algorithm. For example, uh, if I have multiple clients, okay, or this single client is establishing multiple sessions, okay, in that case, the traffic will goes to the first VM, then second session it will goes to the second VM, for third again it goes to the third VM. Again, like the cycle starts from VM1. The fourth session will reach VM1, and fifth will reach VM2, and then sixth will reach VM3. Okay, so this is how it works at the back end, but it will not support some advanced features which is offered by our AVI load balancer. Now let's try to understand how distributed load balancer works across all three ESXi hosts. Now look at this diagram. We have a DLB which is there in all three ESXi hosts, right? Okay, so here you can see that all three ESXi hosts have distributed load balancer. So the natural question which comes to the students, like is every ESXi has a load balancer? Then who is the leader? Because someone should be the leader to pass the traffic to like spread the traffic across all three VMs, right? Okay, so there is no leader in distributed load balancer, and there is no active, no standby, no master node. This is not like our edge load balancer or FI. Okay, so here distributed load balancer is completely leaderless. Okay, now let me explain how traffic actually flows in a real production support. Okay, so here first the client VM sends traffic to the VIP. So that is very clear. Okay, because from load balancer perspective, the client VMs will reach the load balancer IP only. In our case, it is 10.40.30.50 with the port 8080. Okay, so this client VM is running on one ESXi host, at least like it will be in a cluster, right? So at a time, the client will be running on only one ESXi host, not on all ESXi hosts. So the point is very important here, because the ESXi host where the client VM is running becomes the decision making point for that traffic. Because as I told you, when the traffic hits this load balancer IP, then someone has to take a decision, right, to like share the load across all these three VMs. So here the decision making point for the traffic is the client VM's ESXi host. Okay, that is going to take a decision here. Okay, so that what will happen, the distributed load balancer will decide where the traffic should go. Then ESXi host and ESXi host 3 are not involved in that decision. Okay, now the next question is like, how does ESXi host one decide which VM to send traffic to? Okay, so that question might come to you. Okay, then in that case, it is going to use an hashing algorithm at the backend. Okay, the hash might be calculated using some client IP or like virtual IP address or destination port. Okay, and the protocol. The protocol here is TCP, right? So based on this hash, the load balancer like selects one backend VM. Okay, and then it may go to app 1. For the next connection, it may go to app VM2, and for next connection, it may go to app VM3. This is how a load is distributed. Okay, now the important point is like, what if app VM2 is running on ESXi host 2 and the client VM is on ESXi host 1. Okay, so here in this example, see the screenshot here. Client VM is running on ESXi host 1, but it wants to reach the app VM2 which is running on ESXi host 2. Okay, now let's try to understand that. Okay, here ESXi host 1 will select app VM2 and the traffic will simply travel across the NSX fabric to ESXi host 2. And the distributed load balancer does not care which ESXi host the backend VM is on. Okay, all ESXi hosts have the same load balancing rules, the same backend pool, and the same algorithm. That's why this works perfectly without any leader concept in NSX. Okay, now think about the vMotion. Like in production, we'll be enabling DRS and DRS will do the vMotion, right? If the client VM moves from ESXi host 1 to ESXi host, then what happens? So nothing is going to break here. Now ESXi host 2 starts making the decision balancing, the load balancing decision using the same logic and same configuration, and there is no failover or like no re-election, no disruption, like related to the leadership concept. So this is exactly why VMware calls this as a distributed load balancer. Okay, so just remember this. Okay, distributed load balancer has no leader. The ESXi host where the client VM runs makes the load balancing decision related to NSX DLB. Okay, so if you understand this, then you can like from production perspective, you should have a good understanding if it is configured. Okay.